So continuing on with our modeling of different types of functions, now we're going to model a function based upon a graph. So as you can see, this is talking about the Deep River Gorge, and obviously this looks to be a parabola-shaped figure, and therefore a quadratic type of equation. So in answering the first part, this is a quadratic function. It's a parabola shape. Okay. So what are the quantities? F of x, which is y, is height in miles, and x is distance in miles. Okay. How would you describe the n behavior? It opens upward, which is important when we're going to get to our value of a. What is the general form? Well, we actually have three different forms that we can use. We can use f of x is equal to ax squared plus bx plus c, which is standard form. Or we can use that it's equal to a times 8x minus h squared plus k, which is vertex form. And then finally, we can use a times x minus m, x minus n, which is factored form. And again, depending upon the information you're given, that will drive the type of form that you may use. Okay? Now, how does knowing the function, the type of n behavior help us here? So we know the function is a second degree, meaning x is squared, polynomial, and the leading coefficient is positive because it opens upward, meaning a is positive. All right, so if you might remember, we have, I'm going to write here the three coordinates from the first page. So we have 0, 5, 1, 0, and 3, 2. Okay. So we don't have two zeros given to us, so factor form isn't on the table. So if you might remember, in one of our earlier units, we used our systems of equations to help us. So the first thing we know is c is equal to 5, because 5 is our y-intercept. So we know that we can do our first equation as 0 equals a times 1 squared plus 1b plus 5. That's using 1, 0. So that when I simplify all of this, I'm going to get negative 5 equals a plus b. Okay? All it is just simplifying what this equation is so that I get a and b on the same side. Then I have 2 equals a times 3 squared plus 3b plus 5. And when I simplify all of that, I'm going to get negative a. Actually, I'll go a step before that. You're going to get negative 3 equals 9a plus 3b. And I'm going to divide everything by 3 and get negative a equals 3a plus b. So now I'm going to use those two equations. I'm going to move this equation over to here. And I'm going to solve these simultaneous equations. So I'm going to multiply the top one by negative 1. So that I'm going to get 5 equals negative a minus b. and negative 1 equals 3a plus b. 4 equals 2a. 2 is a. And then when I plug in 2 for a, I'm going to find out that b is 7, so that I find that my equation is f of x equals 2x squared plus 7x. Did I get b? Let me just check something. Hold on 1 second. B is negative 7. I'm sorry. Negative 7. So 2x squared minus 7x plus 5. Okay. So what are the key features of the graph that can be used? We used the y-intercept. And again, you check this, you plug that into your calculator and make sure all 3 points show up. The y-intercept and 2 other points. Which key features of the function must be determined? Okay, so the zeros and the vertex. So now how do I do that? Well, the zeros, by seeing that one of my zeros is the number 1, that means it's factorable. So I would do f of x equals 2x squared minus 7x plus 5. So I'm going to set it equal to 0. So if one of my zeros is x equals 1, then that means right before that as x minus 1, which then means this has to be 2x minus 5, which gives me my other zero of 5 halves, which when you look at the graph, looks about where it crosses the x-axis. Okay? To find my vertex, I'm going to use negative b over 2a. So negative a negative 7 over 2 times 2, or x equals 7/4. And then to find the y that goes with it, I would plug it in and find that it's negative 1 and 1.25. Okay, which also seems to fit what we see in the graph. All right, continuing on. What domain makes sense? The domain should be x is greater than or equal to 0, since it is distance. Okay. How wide is the bridge with one side located at 1, 0? Okay. So it is the difference between the x coordinates of the x-intercepts. Okay? So when I do that, it's 2.5 minus 1.0, or 1.5 miles. So all it is it's that horizontal distance between my x-intercepts. How high is the bridge above the bottom of the gorge? It's the y value of the vertex, which is 1.125 miles. Okay? Suppose the gorge is exactly 3.5 feet wide from the 2 highest points. Okay? So find the average rate of change. So the average rate of change is 0 since these 2 points are symmetrical and form a horizontal line. And then finally, how can you check to make sure your function models? You can use your calculator to verify the points. Okay? All right, so that's our modeling from a graph, which is very similar to work we did earlier in the year.